All these 10 signals you can see are of equal bandwidth. So the question is, how can I put first signal in the first frequency slot, second signal in the second frequency slot, and so on. This will be done with the help of modulation. We all know that in process of modulation, we convert the low frequency signal to high frequency range. And to what frequency range the signal gets converted to depends upon the value of the carrier frequency. If you remember, in double sideband full carrier, the new frequency range that we get is from Fc minus Fm to Fc plus Fm. Whereas in single sideband techniques, this can go from Fc minus Fm to Fc if it is lower sideband. If it is upper sideband, it will go from Fc to Fc plus Fm. So now it becomes very obvious to understand how we will put signal number 1 into the first frequency slot. The first frequency slot starts from 1 megahertz and goes up to 1.1 megahertz. So all we have to do is take the carrier of value. So my FC1 will be 1 megahertz, and it will give me the sideband from FC1 to FC1 plus FM1, which will be from 1 mega to 1 mega plus. FM1 will be bandwidth of each signal. We have assumed all the signals of 100 kilohertz. So 1 mega plus 100k will give me 1.1 megahertz. How will you fit signal number 2 in the second slot? For the second signal, so this was for signal number 1. For the second signal, signal number 2, I'll take FC2 equal to 1.1 megahertz. Now if FC2 is 1.1 megahertz, then my single sideband, the frequency range for modulated signal with signal number 2 will go from FC2 to FC2 plus FM2, which will be FC2 is 1.1 mega plus 1.1 mega plus FM2 is again 100k, because each signal, FM2 is the bandwidth of the second signal, but all the signals that we have taken are of the same bandwidth 100k. So you can see this will be nothing but 1.1 mega to 1.2 megahertz. And likewise for the last signal, this is FC1 and FC2. If I consider signal number 10, for signal number 10, FC10, the 10th carrier frequency will start from 1.9 megahertz. And if I do the similar calculation, then the frequency range for the single sideband will be from 1.9 megahertz to 1.9 plus 100k, which will be 2 megahertz. So that will be the last frequency slot. So this is how frequency division multiplexing can be achieved with the help of modulation, in which we will use different carrier frequencies. And we use single sideband modulation so that we can make maximum use of the available bandwidth, as single sideband signal requires the bandwidth which is half compared to the bandwidth of double sideband. Let us now go to the block diagram of FDM system. So this is the block diagram of FDM system, frequency division multiplexing. The left hand side is the transmitter side of the FDM and the right hand side part is the receiver side. You can see there are n number of message signals, message input, or you can also call them information signals, 1 to up to n. So there are n number of signals here. We are passing through the signals first through the low pass filters. This is done so that we ensure that every information signal is restricted in terms of its bandwidth. For example, in the previous video clip, we said that we are taking 10 signals each of bandwidth 100 kilohertz. So you have to make sure that every message signal does not have bandwidth greater than 100 kilohertz. So the low pass filters are used to restrict the bandwidth of the message signals to the specific value. Now comes the second step in the transmitter side, which is the modulation. So we give output of low pass filter, which is nothing but my original message signal with bandwidth restricted to a specific value. We give it to the modulator. And you can see to modulator, the second signal, which has to be the carrier signal, so I'll call it FC1, the first carrier frequency, comes from a block which is called carrier supply. So there's a carrier supply block which will supply carrier frequency to the modulation. To the second modulator block also we are giving second signal and the carrier frequency, but this time it will have a different value FC2. So this carrier supply block will be nothing but something similar to frequency synthesizer, which can generate different carrier frequencies.